You've already seen that local lets you have definitions that are available inside the local. But what does that mean exactly? Are they available outside? What if there's a definition outside the local and inside the local that has the same name? What if there's a local inside a local, or even one more local inside of that? In this video, I'm going to talk about the concept of lexical scoping and show how scope contours will let you answer any such question about local. In this video, I'm going to talk more precisely about what it means to say that local sets up some definitions inside the local expression. To do that, I'm going to introduce an important concept in programming called lexical scoping. Let me set up a little problem here for us to think about. Let me get rid of that local expression, and I'll say define P is incendio. Now, the question is, if I run this program, what am I going to get? Am I going to get Accio port key or incendio port key? I'll put a space there. That's not key to the problem. Which of the two am I going to get? Well, I'm going to get Accio port key, which is the one I want, of course. But the question is why? And in order to talk about that, I'm going to introduce this concept of lexical scoping and scope contours. So, the first thing to understand is that in a program, there's a thing called the top-level scope, the global scope, the scope of the whole program. So the way to think about that is that there's a box kind of around this whole program. And every definition in that box is recorded in the box. So in this global or top-level scope, we have recorded the fact that there's a definition for P. So there's a little notation here that says, hey, there's a P in this box. Then whenever we encounter a local, we make another box just around the local. And every definition that's in the local gets set up in that box. So whereas the top-level scope, the top-level box just has P, this inner scope, this inner box, has P and fetch. Okay? So that's the first half of lexical scoping. The second half is, what do we do whenever we see a reference to a constant or a function? Well, here's what we do. It's easy. We start right at the reference, and we go to the innermost enclosing box. And we see if that innermost enclosing box has a definition for that reference. So starting at this P, we go to the innermost enclosing box, which is the box of that local, and we say, hey, is P defined here? And the answer is yes, it is. And then that's it. We're done. We know which P this is. It's the P that we find in the innermost enclosing box that defines it. So this P here is the one from this box, so it's Accio. Okay, now let's look at a little bit more complicated case. I'm just going to paste it in here. Here's a little bit more complicated case. Well, what's this going to produce? Before we run it, let's try to use the scope contours to figure it out. In the global scope, there's going to be two definitions, A and B. And it's these definitions here, where A is 1 and B is 2. And way down inside this local, there's going to be one definition for B. And in this definition, B is 3. So now let's go look at all the references. What are they each going to be? Well, this first A, we start at the reference A, and we go to the nearest enclosing box, which in this case is the global scope, and we say, is there an A there? Yes, there is. There's an A here, and so that A would go to this A here. We'll just draw a little arrow that says that that A is that A. That reference to A goes to this definition of A. Okay, now let's find the next reference in this program. Well, here it is here after the plus. It's this A right here. Well, which A is that? We don't know. Let's go to the nearest enclosing scope contour. It's this inner box. Does it define an A? No, it doesn't. Let's go to the next nearest enclosing box. It's the outer box. Does it define an A? Yes, it does. So this reference to A here goes to the global definition of A there, or the top level definition of A there. Okay, what about this B? Well, we do the same thing. We start at the B, we go to the innermost box, we say, does this box define a B? Yes, it does. So this B goes to the inner definition of B. Let's go to the next reference. Now let's be careful. This B here is outside of the local. So when we go to look at the nearest and closing box, it's the global scope. So which B does this end up being? It ends up being the global B. So with these arrows on this, we can kind of see that, let's see, this is going to be plus 1, also 1, 3, and 2. 1, 1, 3, and 2 is, I think, 7. Sure enough. Let me suggest that you do some exercises. I'm about to give you some to do with these scope contours. And you can kind of check your work automatically with Dr. Racket, but please, 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 let me encourage you to first try to solve these problems on your own before you use this trick I'm about to show you to check your work. In Dr. Racket, in the intermediate student language, when you've got locals, if you click on Check Syntax, and then you hover over a reference, it will draw a line from the corresponding definition. If you hover over a definition, it will draw lines to all the corresponding references. Okay? So that B is that B. Right? So you can check your work this way. It doesn't draw the boxes. It doesn't draw the boxes, but it does draw a line showing you which A it is. So you can use that to check your work, but please, please, please practice some of this scope contour stuff without using that. It's really important to understand the idea of lexical scoping without using an automatic tool to answer the question for you.